Jai Hind everyone, myself Sandeep Yadav. Today I am going to deliver a lecture on NoSQL, which is a part of curriculum of B.Tech subjects Big Data being taught to various B.Tech students, either CS, CSE, CSE Hindi or IT, CSIT and various other disciplines. So the topic is very well apt, NoSQL databases. Well, every one of us is familiar with the word SQL, which stands for Structured Query Language, which is a standard query language being used in relational database to perform various operations such as insertion, deletion, updation, and retrieval, as well as to create various database objects. Well, today our objective is towards the NoSQL, that is not only SQL. Let us see the main concepts of NoSQL. Well, NoSQL means not only SQL. See, this NoSQL offers robust advantage over SQL. That is, it has no fixed table schema. It does not store data in row and columns only, and there is no concept of join here, right? No concept of join is there, and there is no concept of join here, and no multi-document transactions are there, and it relaxes the ACID properties. That is, we need not to adhere to all the ACID properties. We can use also the cap properties also. So types of NoSQL. See, NoSQL is of 4 types basically: key value data store, column oriented data store, document data store, and graph data store. In key value data store, the concern is key values which are associated. Now the various examples are React, Redis, and Membase. And columnar oriented approach, all the data internally is stored in the form of columns. See, in analytics, mostly the data operations are relates to querying certain columns. So instead of processing all the table scan, we just process a particular row, and for that we have the columnar oriented database, that is Cassandra, Hybase, and Hypertable. Next is document data store. The prominent among them are MongoDB, CouchDB, and RavenDB. All of you may have studied the MongoDB in your previous semester in web technology, where the concept is that there is a document for each of the entry. For if we have 10 records, then we will be having the 10 documents. All the documents are collected together to form a collection. Last one is the graph data store. Infinite graph is there, Neo graph is there, and Allegro graph is there. That is basically dealing with the social media data, which is being generated at vast pace these days. So to sort out that, we have been using the graph data store, which basically shows the hierarchical nature of the data. Now, advantages of NoSQL. So first of all, it is very cheap and easy to implement. Second, it offers the advantage to distribute the data across several terminals or several nodes in a highly distributed environment. And NoSQL can easily be scaled up and down. So we can increase the number of nodes up and down. Scaling is of 2 types, as we know, that is horizontal scaling and vertical scaling. In horizontal scaling, what we do is we add the more number of nodes to the existing systems. That is, the number of components increases or the number of the system increases. Whereas in vertical scaling, we increase the computing power of the system by increasing RAM and hard disk and all those things. Now so NoSQL offers the easily upping of the scaling or downing of scaling depending on the requirement. Next, it relaxes the data consistency requirement. That is, we need not to adhere to the traditional data consistency requirement. That is, we can use the cap theorem also, because here we have to use the concept of eventually consistent. We cannot be consistent at all time, but ultimately we should be consistent. Prominent among them are the Amazon database, which is Amazon is there, and product is DynaDB is the product of Amazon, and it is mostly used on LinkedIn and Mozilla. Second is Facebook. Facebook is generally use the Cassandra, that is, it uses Cassandra, and most wide users are the Twitter, Netflix, and eBay. Twitter is nowadays known as X also. Earlier we use Twitter, now we use X. So various tweets are there, so we can easily use NoSQL for that particular purpose. And eBay is a very big retail store, and that also uses this Cassandra. And who don't know the Netflix? All of you are aware with Netflix. So Netflix is also using Cassandra. Next product is Bigtable, which is being developed by Google, and this is mainly used by the Adobe Photoshop. Let us see the difference between SQL and NoSQL. This is very important, children, and this is asked in examinations also and various interviews also. So it should be emphatic on you people that you should have the clear-cut difference in your mind while either for the examinations or for the competitive exam. Well, SQL is for the relational databases, whereas NoSQL is for the non-relational and distributed database. SQL has been following the relational database, which were given by code. So SQL follows the 12 rules of the code, whereas in reality, no relational databases follow all the rules. Some follow 8, some follow 7, some follow 9 rules. So like that. And NoSQL is model-less approach. There is no particular model which needs to be used. Again, next difference is SQL has predefined schema. Yes, SQL has predefined schema. We cannot enter any attribute other than the predefined attributes. Every entry should be in the predefined schema. Whereas NoSQL has dynamic schema, that is for unstructured data. That is, you can enter the attribute, whichever attribute you want. Next is table-based databases. SQL databases are table-based databases, right? The difference based on the scalability. NoSQL is basically more vertically scalable. That is, we increase the computing power of the system, whereas NoSQL is horizontally more horizontally scalable. That is, we are adding more number of commodity softwares or hardwares or whatsoever the component we were. And SQL uses here we are using SQL, since it is SQL, so it will naturally using SQL. And here we are using unstructured query language. Unstructured query language, that is no defined query language. And SQL is preferred for smaller data set, now preferred for larger data set, whereas NoSQL is basically preferred for larger data set. And next difference is that SQL is not suitable for hierarchical data, whereas NoSQL is suitable for hierarchical data as it follows key value pair storing, that is similar to JSON, where JSON is JavaScript object notation. Now, next very important concept is the concept of properties. So it follows the ACID property and it follows the cap theorem, Brewer's cap theorem, where C stands for consistency, A stands for availability, and P stands for partition. Whereas in acidity, A stands for atomicity, C stands for consistency, I stand for isolation, and D stand for durability. So NoSQL has to basically follow the CAP theorem. So it does not guarantee the fulfillment of more than two component at a time in CAP theorem. We can also get three, but in case of failure, maximum two are guaranteed. Next is, whereas the SQL prefers the acid properties, that is, it lays emphasis on acid properties. Acid properties are atomicity, consistency, isolation, and durability. Atomicity ensures that the total should remain the constant, and C stand for consistency, which ensures that the state of transition before the state of database before the transition and after the transition should be correct. It should not reflect incorrect data. And I stand for isolation, which ensures that while several transitions are running in parallel, they should not interfere in each other's work. And D stand for durability, which ensures that the changes are made persistently in database. Whereas in CAP theorem, C stand for consistency, A stand for availability, and P stands for partition tolerance. That is, system should provide the fault tolerant services. Next important difference is that SQL has excellent support from the vendors, whereas this relies main on NoSQL relies main on the community support. And SQL is used for complex queries and data keeping needs, whereas NoSQL does not have very good support for complex queries. And SQL can be configured for strong consistency, whereas NoSQL support only few strong consistencies like MongoDB. Few other can be configured for eventually consistency. Here we are using the term eventually consistency. Eventually consistency means that after some time there will be consistency. Right now, if there is a primary copy and we have made change here, then those changes are not reflected in other copies at same moment time. It takes some time to reflect the changes. Ultimately, when the changes will be reflected, it will be eventually consistent. Now, various example of NoSQL based database which are using SQL are Oracle, DB2, MySQL, MS SQL, Postgres, etc. And of NoSQL databases are MongoDB, HBase, Cassandra, Redis, Neo4. So it is a SQL interface for application interface, and it supports the ACID property for the transition, and it provides an architecture that provides higher node performance via traditional vis-a-vis traditional DBMS. And it also provides for the scaled out, that is the shared nothing architecture, and it has the various no locking concurrency control techniques so that real-time reads will not conflict with writes. Now we are discussing something about Hadoop. So Hadoop is an open source software framework that is mainly used for the data set that is highly unstructured or semi-structured. It is basically used in big data. It was inspired by the Google MapReduce and Google file system which was used earlier, and later on it took the form of HDFS, Hadoop distributed file system, and MapReduce. Now the key advantages of Hadoop are: it stores data in its native format, it is highly scalable, vertical as well as the horizontal, it is cost effective and resilient to failure, that is, it provides fault tolerance. Next, it is highly flexible, as it can handle all the type of data, and it is very fast. It provides a faster response. The various versions of Hadoop are there. So we have two versions, Hadoop version 1 and Hadoop version 2. Hadoop version 1 consists of MapReduce. Here the functions are cluster resource manager and data processing, whereas in version 2 MapReduce has only one duty, that is data processing and not cluster processing. And in version and the duty of cluster resource manager has been given to the yarn in Hadoop version 2. And in Hadoop version 1, SDFS provides for the reliable storage, and in 2 also it provides the reliable storage. So basically what is the difference is that yarn has been added in second version. Yarn has been added in second version. So we have the yet another resource negotiator. This is the ecosystem of Hadoop. That is, at the topmost we are having the Ambari, which stands for provisioning, managing and monitoring the Hadoop clusters, and the core is the SDFS and the MapReduce. Then Scoop and Flume are there. Scoop is basically for the relational database, and Flume and Chakwa are for the log related database collectors. And SDFS is for the storage management. The storage part is being taken by the SDFS. We can use various SDFS commands or CLI or Java interfaces. And for processing, we can use MapReduce or we can use Spark also. MapReduce is basically used for batch processing only, whereas Spark can be used for both. Spark can be used for both batch plus real-time data. See, real-time data can be of any type, whether structured, semi-structured or unstructured. And in addition to that, we have the HBase, that is distributed table store, distributed database table store. Then we have the OG for the workflow management and Zookeeper for the coordinating events. And for ML, we are having the Mahout, and Pig is a high level data flow language. R is basically used for statistical purpose, and Hive is basically used for data warehouse. And for data ingestion, we are using Scoop, Flume, Chakwa or Kafka for data ingestion, that is integration of data from different sources. The sources can be structured, semi-structured or unstructured. So these are the various components that I have just discussed. See, for data ingestion, we have already discussed Scoop and Flume, and for data processing are MapReduce and Spark, and Tej can also be used, and for data analysis are Pig, Hive and Impala we can use. Impala is for Hive. So the three differences between the HBase and the Hadoop database is that SDFS is the file system, whereas the HBase is Hadoop database. It is like NTFS and MySQL. Next is SDFS is warm, write once and read multiple times or many times. Basically, in the analytics portion, most of the time what we are interested in read operation, write is seldom performed. So latest version supports appending of data, but this feature is rarely used. But HBase being for the distributed purpose, for the storage purpose, it supports real-time read as well as write. And Hadoop is based on Google file system, whereas HBase is based on Google Bigtable. Next component are the Scoop and the Flume. Scoop stands for SQL to Hadoop. It can provision the data from external system on SDFS and populate tables in Hive and HBase. Whereas Flume is an important log aggregators, which collect data from different machines and put them in SDFS components. Now, MapReduce is a programming paradigm that allows for distributed parallel processing of huge database. It is based on Google MapReduce. In Map, we are having the division of files in different components which are being executed through different maps, and in reduction we are having the aggregation of the same. Spark is programming model as well as computing model. It is written in Scala. It provides for the inner memory computation that is 100 times more faster than the MapReduce. Now in Spark we can use both. Pig is a high-level scripting language used with Hadoop. It serves as alternate to MapReduce. It has two scripts, Pig Latin and Pig Runtime. Pig Latin is like a SQL scripting language, whereas Pig Run is the runtime environment. Hive, we have already discussed. It is a database house built on the top of Hadoop, and it is used for summarization, query, and analysis. And Impala is a high performance SQL engine that runs on clusters. Cluster is a collection of various nodes and that appears to be providing as services as a single system. To user, it appears that it is a single system. It is a collection of different systems. So cluster Impala is ideal for interactive analysis. It has a very low potency, that is response time is very fast, and it supports a dialect of SQL called Impala SQL, which can be used for query purposes. Thank you. That is all. I hope it is clear to all of you, and we will be proceeding with next topics in next lecture.